Now we're going to look at rational inequalities with linear equations. So linear equations mean that the highest power of x is 1. So now we're going to look at how we solve those rational inequalities. The first and most important thing, just like quadratic inequalities, we always make it equal to 0 because 0 is a number that has particular properties. So let's look at the rational inequality we have there now, and we'll discuss that property of 0 just now. 4x minus 1 over x plus 2 is less than 0. Just because it is compared to 0, we know a few things. So if there was not a less than sign, but there was an equal sign, one fact that we know that if a fraction is equal to 0, then the numerator has to be 0. That's the only way that can happen. So we can apply this right here. So if we go 4x minus 1 over x plus 2 is equal to 0, a fact that we know is that 4x minus 1 equals 0, right? Then we transpose to find a value of x when this inequality is equal to 0. So when we transpose, we get 4x is equal to 1, so x will be 1/4. Another fact that we know about inequalities is that the denominator can never be equal to 0. Because if we divide by 0, we get an undefined fraction. So therefore, in this fraction, we know that the denominator cannot be 0. So we have to find that value of x that we put in this fraction that makes the denominator 0. So that will be x plus 2 equals 0, so x is -2. But I should say that it is not equal. X can never be equal to -2 because if we place -2 in this, that will give us a denominator of 0, and that is not possible. So let's look at what we have here. We have one value of x, right, when the numerator is equal to 0, and we have another value of x of importance when the denominator cannot be 0. So these are the two reference values that we use for us to determine our inequality. Now what do we do after that? So what we do after that is what I like to call to check where does our intervals lie. So like in the graphical method, we had used the x-axis to check if it's in between the roots or if it's outside of the roots. So we can look at it the same way. These two values of x are our base values. So we're going to check, does the inequality lie, or is it true, I should say, between these two values, 1/4 -2, or is it outside these two values? So what we're going to do is we're going to draw a table and we're going to put those values in. So we start with the lowest value, which is -2, and then we will go to the higher value, which is 1/4. Notice I left a space in there because we have to check in between and outside. So let's do that. So what I'm going to do, so all these things here are my x values. So now I'm going to say, let me think of an x value that's in between -2 and 1/4. An x value I can think of is 0 because 0 lies between, on the number line, it lies between -2 and 1/4. So we put 0 here. So now we check. If I put 0 in this equation, what happens? So we say 4 times 0 minus 1 over 0 plus 2. So this gives us 0 minus 1 is -1 over 2, -1/2. So now we say, is -1/2 less than 0? It is. So therefore, this is correct. So yes, it lies within the function. Because when we put 0 in here, if we put 0 in here, then we get -1/2, and -1/2 is less than 0. So that is true. Next one. Let us look for a number that is greater than 1/4. So that would be the lovely number 1. So let us take this out, and then now we're going to substitute when x equals 1. So we say 4 times 1 minus 1 over 1 plus 2, which is equal to 4 minus 1 is 3 over 3, and that is equal to 1. Is 1 less than 0? No, that is not true. So this is not satisfied. Then we take a number less than negative 2. So I will take, let's say, negative 3, and then we check. X equals negative 3. I'm over here on the left. So we go 4 times negative 3 minus 1, right? And that will be over negative 3 plus 2. So that's negative 12 minus 1 is negative 13 over negative 1. So that gives you positive 13. Is 13 less than 0? No, it isn't. So this does not satisfy. So therefore, I can write a statement saying that x is in between negative 2 and a quarter. So how would we write that? So our solution would be, our lowest value is negative 2. X lies between negative 2 and 1 quarter. So this is our solution. Okay, let's do another example. We have a second inequality. 3x minus 2 divided by x plus 3 is greater than or equal to 1. Now, first of all, just looking at it, we already see that something is different. The inequality is compared to 1. And this is something we don't want. So our first step is to put it in the format that we need it to be. So we go 3x minus 2 over x plus 3, and we subtract 1 is greater than or equal to 0. But we need to make this a rational equation. So all we do is we find the common denominator like we do in other fractions. So our common denominator is x plus 3. So the first part will be the same, 3x minus 2, but we're going to subtract x plus 3 because 1 is the same as x plus 3 over x plus 3. Okay? And then we're going to simplify. So that'll be 3x minus x is 2x, and negative 2 minus 3 is 5, negative 5, sorry. And then we have x plus 3 as our denominator. So this here can be rewritten as 2x minus 5 over x plus 3 is greater than or equal to 0. Okay, so now let us solve our inequality. So we first look at our numerator. And our numerator is 2x minus 5. So 2x minus 5 equal to 0. That makes x equal to 5 halves. Okay, and then that's our numerator. And then we look at our denominator to find our second value of x. That will be our reference values. Remember, the denominator cannot be 0, so x plus 3 is equal to 0, so x will be negative 3. So this is the value of x that we cannot have. So we have 2, x plus 5, and x minus 3. And we do our same table. So we put in our two values. Negative 3 is the lowest, so it comes first. And 5 on 2 is the highest, so it comes second. And just For those who don't know what 5 on 2 is, 5 on 2 is the same as 2.5. I just like fractions, but if you're more comfortable with decimals so you can picture it on the number line, I'll put the 2.5, but try to work with fractions. So let's find values in between and on the outside. I like to start with in between first. So a number in between -3 and 2.5, again, picture your number line. 0 lies in between the two of them. So we place 0 in our inequality. Now we can use either this one or this one. It does not matter because both of them are the same thing. So let's go. So we place 0. When x equals 0, let's put it in our equation. I will use this one. So when x equals 0, 3 times 0 minus 2 over 0 plus 3. So this will be -2 over 3. Is -2 over 3 greater than or equal to 1? No. So therefore this does not work. Let's look at our next value. We need a value that is less than -3. A value less than -3 is -4. Again, just picture your number line. So when x equals -4, 3 times -4 minus 2 over -4 plus 3. So -4 times 3 is -12. -12 minus 2 is -14. And then we have -4 plus 3 is -1. So this is actually +14. So is 14 greater than or equal to 1? Yes, it is. So this one out here is true. And our last one, a number that is greater than 5/2, and that a number is 3. So we put 3 here. And then we say, to your left here, when x equals 3, then we have 3 times 3 minus 2 over 3 plus 3. And that will be 3 3s are 9. 9 minus 2 is 7. 3 plus 3 is 6. So you have 7 6, which is 1 whole and 1 6. So is 7 6 greater than or equal to 1? Surely is. So now we see that our equation is only satisfied when it is less than -3 and when it is greater than 5.5. But let's look at something. We also have the equal sign right here. Okay, so we have to know what values. So we include our -3 and our 5/2, but one of them we cannot include. Which one do you think it is? If you guess that x is -3, then you are very correct, because x can never be -3, because if x is -3, then we will end up having 0 in our denominator. So x cannot be equal to -3. So keep that in mind. So let's write our solution. Our solution will therefore be x is less than -3. See that? And that is in union with x being greater than or equal to 5/2. So this is our solution. And this is how you solve rational inequalities with linear equations. So right now, take the time to do some practice and answer the questions assigned.